How do we quantify sound? What is the amount of sound? Well, that's easy. It's the volume, right? The volume. If you have a lot of sound, you have a high volume. If you have a low sound, you have a low volume. Well, that's not how we do it in physics. Of course, we have a more technical way. We keep up with how much sound. You might say, well, in physics, it must just be the amplitude of the wave. Yeah, well, that would be nice, but that's not how we do it either. Sound intensity would be the technical way, and really intensity can be used to describe any wave. It's how much power you're sending per unit area. So for now, we'll say for sound, we're talking about it, it's how loud the sound is, proportional to the amplitude of the wave. So let's say you've got a speaker here like this, and there's some sound coming out of it. I'll draw like that, just blasting out. The intensity, I, it's really just the power in the wave per unit area. Okay, so the speaker may give you a certain power. Say it's a 700 watt speaker, right? That's in joules per second. You know what that is, energy per time. A joule per second is a watt, so this is how much energy it's cranking into the air every second. But then intensity means something else, means how is that spread out over a certain area. So intensity is the power per unit area. And let's see, then if we think about this speaker, let me draw it again. So now if we have, say, a little speaker like this, let's have it going out in all directions. So let's say it has some power P in watts, and it's sending out a sound like this, then intensity drops away from the source. Okay, so if this were putting out a power P and you went a distance R away, it would be that power per unit area. So here at point A, the intensity at A would be the power, say, I don't know, 700 watts, over, if it were going out perfectly smooth in a sphere, it'd be the area of that sphere, which is, area of a sphere is 4 pi r squared. 4 pi r squared. So that's how you could calculate the intensity. But what you're more likely to be asked is, how does the intensity change if you went 2 times as far away? If you came out here to 2r, well, you can call that point B. Well, the intensity at point B equals that same power, it's only got a certain amount of power, 700 watts, whatever it is, over 4 pi, and then you'd put 2r squared. So the 2 would get squared. So since it goes down, since the intensity goes as the area and the area goes as r squared, the intensity would drop by a factor of 4, right? Twice as far away, 1/4 the intensity. 3 times as far away, 1/9 the intensity. Right? You got to square it. And that may sound, I mean, it looks fine on the blackboard. It doesn't sound right though, does it? If I have a speaker and I'm sitting here listening to it, it's at some volume, and if I get twice as far away, it doesn't sound 1/4 as far down in intensity or in power or what I hear, right? The volume doesn't go down by a factor of 4. And there's sort of 2 reasons. One is that a lot of times the sound is being sent sort of more collimated, right? This is just going out in space. Very few speakers just send their sound just completely out in a sphere. So it might be more focused to go straight and not spread out as much. But another reason that's more interesting is that your ear is not linear. Right? If the intensity goes down by a factor of 4, your ear doesn't tell your brain the volume is down by a factor of 4. Your ear is more logarithmic than that. And that way, you can hear a large range of volumes. Right? If your ear were linear, you could hear something loud and something not so loud by a factor of 10 or 100 maybe. But since it's logarithmic, you can hear a big mean animal that's about to eat you or a teeny little animal that you're about to eat, right? So we evolved to hear a large range in sound. So yeah, your ear, don't use your ear to try to do these problems, just use your math.